Hello, today we're going to be looking at lesson 2.6, exponents. So just as a very basic introduction to exponents, what we need to remember is there are really two components. There is the base and there's the exponent itself. An exponent is used to represent how many times something is multiplied by itself. So for example, if we had up at the top here the expression or let's say 7 to the third power. What we're really saying there is to multiply 7 by itself 3 times. Now, a common error is to say 7 to the third is equal to 21, and that is false. 7 to the third really is saying 7 times 7 times 7. So please make sure that you understand the difference. It may come at first to you, you might be thinking multiplication, and it is multiplication, but it's not multiplied by the exponent. The exponent is simply telling you how many times to multiply that base by itself. So in example 1, we're asked to write in exponential form. When you're asked to write something in exponential form, you are identifying first, what is your base, what is the number being multiplied, and then second, how many times is it being multiplied, which will be your exponent. So if you take a look in A, we have 4 times 4 times 4 times 4 times 4. So we have 4 multiplied by itself 5 times. So quickly we can see that our base will be 4, and then our exponent will be 5. And that is exponential form. In letter B, our base is the letter J. It's a variable, same process though. It is being multiplied by itself 3 times, making our exponent 3. So that's what exponential form is. In example 2, you'll notice that we have negative 5 squared and negative 5 squared. Sounds exactly the same, but when you notice in the second problem, it contains parentheses around the negative 5. And you may be wondering if that makes a difference or not. The answer is yes, it does. So when we look at the first one and we have negative 5 squared, the exponent is only applying to the base itself. Now in this problem, the base is positive 5 versus the second one where our base is negative 5 because the parentheses indicate that that entire term is the base. In the first one, you're almost thinking of this as if it's negative 1 times 5 squared. And so the exponent is only applying to the 5, and if you think of PEMDAS, you're going to evaluate the exponent first and then multiply it by negative 1. So in this case, it's really going to be negative 25. 5 squared itself is 25, then times negative 1 at the end is negative 25. So the negative is not part of the base, it's on its own. So you use order of operations, you square your 5, and then you make it negative at the end. The difference is over here, you could write this out as negative 5 times itself. It is negative 5 squared, so it's negative 5 times negative 5. Well, a negative times a negative is a positive. So here we get a positive versus here we got a negative answer. So real important to remember that difference. Also, if we went back to the first one, negative 5 squared, another way you could write that is the negative would be on the outside, and then you would have 5 times 5 if you were writing it in expanded form like we had up above in example 1. In example 3, we are asked to evaluate these, so we will actually give an answer to them. A couple ways you can do this. I usually break it up a little bit, so if I see this long multiplication problem with many 2's, I might write it as 4 times 4 times 4, and 4 times 4 I know is 16, times 4 again is 64. Then in B, I have negative 3 to the third power. Now notice my negative is inside of the parentheses. So that is part of the base. Now what's interesting in this one is we have an exponent of 3. So really, if I were to write this in expanded form, I have negative 3 times negative 3 times negative 3. the first two negative 3's multiply to give us positive 9. And then we multiply by the third negative 3, which will give us a final answer of negative 27. In letter C, we have negative 7 squared, but this time the negative is not part of the base. So again, we think of this almost like there's a negative out in front and we're multiplying 7 by itself inside. So we do end up with a negative answer of 49. So negative 49 is the correct answer for letter C. Now if we go down to example 4, you'll notice that we actually have some expressions here that we're going to have to simplify. And again, we never want PEMDAS to leave our brains. We need to keep that in mind always. So that certainly applies in this case. We have 36 minus 4 times the quantity 1 plus 3 squared. So automatically our eyes are drawn to the parentheses. That should be our first operation. However, we see that we aren't simplified within there. So we need to first evaluate the exponent because we follow PEMDAS within the parentheses. And so that will end up giving us 36 minus 4 times 1 plus 9. Now I can simplify within the parentheses. So we'll have 36 minus 4 times 10. And I know I need to do multiplication before my subtraction, so I have 36 minus 40. Now I'm taking away a larger number from a smaller, so I know I'm going to find the numbers difference, but I'm going to go into the negatives, giving me a final answer of negative 4. In letter B, we have 5 plus 4 times 4 minus 2 cubed. Again, we are going to be using PEMDAS. So within the parentheses, I need to first evaluate my exponent. So I have 5 plus 4 times 4 minus 2 cubed. 2 cubed is 2 times 2 times 2, so don't accidentally write down a 6 here. It's 8. 2 times 2 is 4 times 2 again is 8. Next, I will subtract within my parentheses. I'm taking a larger number from a smaller number again, so I'm going to go into the negatives. The difference of those two is 4, so it's negative 4. And next I'm going to multiply, so 4 times negative 4 is negative 16. I'm now adding 5 plus negative 16. When I add a positive to a negative, I'm going into the negatives, and the difference of these two numbers is 11, so this would be negative 11. In example 5, small word problem here. It says, the weeds in Mr. Tobin's yard seem to be growing at an exponential rate, terrifying. If the weeds are growing at the rate of 3 times y squared plus y, where y represents the number of weeks they have been growing, if there is, if this is the, let me look at this, I can't see it now. If this is the 4th week that they have been growing, how many weeds are there now? So in this scenario, we're given the expression and we're also told the number of weeks. So if this is the 4th week, that means 4 is going in wherever the y is. This is obviously a fictitious scenario, but it just gives you an idea of how to evaluate it, an exponential expression. So we would simply write our expression down, but this time there will be a 4 anywhere there is a y, so it'll be 4 squared plus 4. And so if we're simplifying this, we'll do our exponent first. 4 squared will be 16. And then we'll add within the parentheses, so we will have 3 times 20. And ultimately we will get an answer of 60. So there would be 60 weeds at that time. Okay, thank you very much.